One thing I can tell you for a fact is I have absolutely no clue what Husqvarna uses for a system. I want to get that out of the way up front. So, you know, I can speculate on the style and the type of system they have, but I have no inside knowledge. This is really a general concept video about how CAD/CAM intersects the saw world, and I don't have any connections or any knowledge about how the different saw companies or what tools or what products they have. I want to get that out of the way up front. But this is an opinion, speculation, and kind of some brain static from my past. I'm going to venture into a little different territory on this video, and you may or may not be interested. When I look at these things here, I look at kind of a triumph of a variety of things. Engineers given us a bunch of design parameters from price, performance, EPA regulations, and coming up with something that can be sold and manufactured reliably, that meets the competitive requirements in the marketplace and the regulatory requirements defined by government. Do it all for a price point and have these things manufactured to a standard where parts can be scattered all over the world and randomly assembled and still have a running saw. It's just, you know, it's a lot harder than people think. A lot of the reason why these things end up being and looking the way they are is because of the design tools. Now this is a concept that is maybe stepping outside of my role as a saw guy, but in my prior life it was right in the power curve of where I lived to talk about. And the concept was, back then, it still is now, that CAD/CAM as a concept and as a technology has a radical influence in how the designs end up and the products end up. The tools that are offered to engineers now are both a blessing and a curse, and that's part of what I want to talk about. In that, because of the capabilities to model and evaluate the geometry, they allow a person or an engineer to take an idea that in prior technologies would have been very hard both to model and replicate accurately. I mean, some of the more complex shapes had to be done by hand. And the advent of the CAD/CAM and then the CAE, or computer-aided design, computer-aided evaluation tools, manufacturing tools, have given engineers more latitude in what they can actually both dream up and replicate in the manufacturing world. And that's pretty spectacular. I watched it happen over the 20 years I was in that business. You know, I was in the manufacturing engineering side, but I was also in the software specification design side in that world, so kind of a unique outlook, you know. Not going to get into it. The company I worked for last was selling software tools to CAD/CAM companies to accelerate the design and proof of concept of some pretty bleeding edge modeling technologies, you know. And it's funny because now, you know, 15 years later, I look back and you're starting to see how some of that stuff impacted the marketplace in a very real way. So, the video is a little bit of ramble. It's a little bit about the 550 Husqvarna, and it's also a little bit of just impromptu mental static for me as I look at these things and react to them. And that's where it gets a little dicey. Should I even put that on video? I don't know. You might find it interesting, you might not. But the net is twofold. There's a couple of very core concepts with the modeling. You know, I'm not going to get into the real basics that most people are going to learn about, whether it's a 2D, 3D, surface modeling base, solid modeling base, a hybrid solid modeler. Is it a B-rep? Is it, you know, what is it? You know, the kind of system that's used will have a performance envelope, and that will in fact affect the kinds of shapes that an engineer can design, manipulate, and replicate in manufacturing. And also that whole thing from conceptual design to a repeatable in a manufacturing environment concept is tough. You know, when you start getting stuff like this, you have the investment casting. None of these things are directly machined. So the whole CNC thing, it's more about building the tools to actually build these parts as compared to, you know, some people thinking, oh my God, some magic wand where you start making these really cool parts with the CNC mill or lathe. Well, usually when it comes to high production stuff like that, it's a tool, one of many, that allows the manufacturer to come up with the tools, whether it's die casting, investment casting, whatever it is they do, forgings, to come up with these complex shapes repetitively, accurately, over a long period of time, so that a side cover made in 2014 can be matched up with a side cover that was made in 2016, and maybe it bounced through the distribution channels for a couple of years, and yet they still go together and can still build a functioning saw. Just really an amazing concept. All these little spare parts, we take it for granted, you know. But when you start getting this complex and you have these tight little spaces where the tolerance stack really can define success and failure in the service life of these things, a lot of that is made possible by the tools that the design engineers have to actually create the conceptual design, the models, before they even get into the manufacturing side of things. Now, the manufacturing engineers, I know, their attitude is, you know, the design engineers are a bunch of idiots. They always design things that can't be made. If they understood the real world, they would have done X, Y, and Z. Of course, the design guys are saying, you know, if those manufacturing engineers would just shut the hell up and do what I tell them, we'd have these awesome products. You know, it's an age-old thing. I find it interesting. And then the marketing guys are saying, when the hell are you going to be able to come up with something like I told you to do, so I can get it to market, make some money, and kick the ass out of my competition? You know, you got to get there quickly. So that whole drive and time to market concept really is behind a lot of this stuff, and that's where my ramblings kind of lead to, is because of the complexity required now. The competition's tough. Steel is no slouch. You know, there's a bunch of other technologies out there, and that combined with the regulation, the kind of world manufacturing infrastructure where the designs may have to get subbed out to other people, and then they still have to connect and fit in the field. All that stuff adds more complexity to the design of a product such as this. Kind of came to mind because I was listening to some of the ramblings online, and me included. I'll complain about things like the particular bearing, or you know, the minutia of the compression ratio and things like that. And the world we live in is, as a hobbyist or a saw mechanic, whatever, we don't have to design the manufacturing process. We don't have to worry about the tolerance of stacks. We don't have to worry about the regulations, the overall design, the liability, all that stuff. All we got to do is find somebody else's world, someone else's design, and tweak it to add our little personal twist, make it a little bit better, and we're a hero. You know, whether it's porting a cylinder or doing a muffler mod or all those things, that's still on a scale of 1 to 10, that's like a 1 in terms of creativity, as compared to the guy or gals, plural, who actually came up with a product design concept. Where is it going to fit in a marketplace? You know, roughly defining the parameters, and then having the design engineers try to fill those parameters in conjunction with their manufacturing infrastructure, come up with a way to build it in a repeatable form and keep the price point where it's competitive, reliable, have a part supply stream going. Just imagine you've made 100,000 of these damn things, and all of a sudden you populate the supply channels with replacement parts like bearings, and all of a sudden you realize saw number 90,001, because of customer feedback, you got to go from one part configuration to a slightly different one. And that's the genesis of this video, because I think that's what happens. And now the engineer is like, oh my God, I don't want to change that part. So let me see what else I can change in the design to help that part survive. You know, Maybe it's a machine part like a crank, or maybe you tweak it a little bit and it does something to either let more lubrication or take more heat away or do something to make a bearing survive, so you don't have to go back and you know, extract. All those spare parts are already out there. The momentum has already been set, but you can come up with these other things that'll nurse that design to a more statistical favorable spot and be successful in the marketplace and not have all these problems. But those larger issues, it's really easy for us to sit back and throw stones. But to be on the other side and try to react to these things, that's just so hard. That's so hard. And as I said at the end of the video, hats off to you guys, all of you. Yeah, it's easy for us to sit back here and pick over your design, but the fact of the matter is this stuff is amazing. These saws are truly amazing. There used to be sort of a family joke where I line all my kids up together and next to their mom, and somebody would say, geez, do they look like brothers? They all have pretty much facial expressions. You know, you guys have had kids. There's a lot of similarities. They're all different, but a lot of times they're very similar. How about in the Husqvarna saw family? Do they look like brothers or sisters, depending if you're a Steel or a Husqvarna guy? And the orange one is the 555. The middle one is a 550, and the one on the top is a 562. And I don't think it takes an educated eye to realize they all came out of the same design house. And some of their common features include the way the ignitions are mounted. You see the wire, they're mounted over here, and the wire goes underneath the flywheel, and they even get a screw at the same place. Of course, the big difference between these two and the orange one is color. Oh, I'm sorry, these are XPs. That's a homeowner or a landowner saw, but the basic layout's the same. And to review some ground on a bunch of other videos, the 555 and the 550, even though they're different displacements, the 550 being 50 cc, so it's being almost 60, they both have the small Husqvarna bar mounts, where the 562 is a large mount. Bearings look the same too, don't they? They both have those nylon integrated seal bearings, and they both have that arrangement right there where there's the external seal and the extended inner race of that bearing. New versions of the 562, the 555 have that additional screw right there. You see them? Where the 550s still have 5K screws. So just a lot of similarities in the designs. How long do you think it's going to be before there's a 70cc version of that saw? Inquiring minds want to know. It's one of the topics online that's pretty common. The 576, you know, it's kind of an oddball, 575, 576, and the 372s are sort of kludges in my mind. Oh, I didn't just say that, but they are. So expect in the future Husqvarna to do what they did in pretty much every other product evolution in their manufacturing history, and that's come up with a full range of saws, different displacements, but the basic design philosophy being the same. I've got a really nice aftermarket top end for a steel-based saw here. The Melee cylinders or Maul cylinders are really nice. This one here is just not bad. Boy, I don't know if I should have this in the video. But quality of these damn things have really gone up over the years. Although the ports, like on this OEM, the ports are just beautiful. Everything. The edges are nice and broken. It's just a the finish and the clarity of those ports is what you'd expect for, you know, original equipment manufacturer type things, to make sure they have the same performance from saw to saw. These, you know, aftermarket, even though it's a different saw model, a little jagged, you know, they can clean up, but there's clearly a difference between the quality. One thing I'm going to mention here, and this is going to get me in hot water. When you start looking at cylinders and you start looking at ways of increasing performance, one of the things guys like to do is cut the base. You know, so you drop your cylinder a little bit. I plan on doing that, but look at the flange. Look how thin that is. How far can you really go? And the answer is you can't do much. You know, look at that. If I get into that, I'm actually cutting into the sealing surface some. So there's really very little I can do to this cylinder to increase the compression. We're on a design like this. Look how thick that flange is. I can take, you know, 20, 30, 40 thousandths and not really hurt the structural integrity of that flange at the base of the cylinder. Which is, by the way, one of the reasons why these things are fun to try to modify is because the little heavier design in places like that give you latitude as a saw tuner to make changes. Just an aside, guys. Yeah, look at that. That's pretty rough in there, isn't it? Now this class of saw, I'm telling you right now, I'm not objective on these. You know, I'm pretty harsh on them, but I'm not objective, and I'll tell you why. Because I like them. There's a lot of people who resist these things and resist the design change. I'm guilty. I mean, I was kind of that way at the beginning as well. But you know, I've got that 562 and the 555 that I've run. This, by the way, is like a knife edge. So I can just sort of slice that off. And instead of gouging the surface with a knife edge, that kind of cuts it nice and clean. I'll have to see how much I edited it out. But anyway, there's the new OEM piston. Interesting little yellow paint there. And notice that the kit came with one wrist pin clip, and that's because the other one's already installed. It's one of those fully captured ones with no tabs. I don't know if the light will let you see that. Yeah, that's pretty much where it has to be. Believe it or not, those cases squeeze that crank. You know, I had mentioned in one of the posts, you notice how complex that shape is? You can blame that on CAD CAM. I'm not going to go there, but in a former life, that was my life, is CAD CAM, CNC, in particular, solid models. You know, complex solid models. It's a really a form of storing geometric data. People don't understand what solid models are in the computer world, but that's what it is. It's just a big database exercise where with one object you store all the bits and pieces and faces, and then from that you can then use algorithms to figure out volumes and intersections with other solids, which are just, again, piles of cyber data. And what you're seeing on these new saws, all these compact designs, these complex shapes, believe me, in years past, trying to do that with a draft board and a pen would have been tough. And in particular, getting all the different interferences, because they're complex shapes and they're in tight quarters. The older saws were simpler simply because the design tools they had pretty much defined how complex a shape they could actually manufacture. The engineer in his head could come up with those damn things, but going from the engineer concept to an actual shape that's a repeatable shape in a manufacturing environment, that's a whole different game. And when you get the complex shapes like this, you know, the other thing that happens, it's almost like CAD CAM is an addiction. You know, because along with solid modeling and surface modeling and the other more sophisticated geometrical definitions that you could do, came with tools to help engineers do designs. You know, conceptual designs, again, the rendering and shading packages, and the solid modelers, where there were levels of associativity to different pieces of geometry and the rest of the model. You know, assuming for example, that case was a solid model or one geometric entity as far as your system was concerned, but it consists of all these different surfaces and faces and blends and all this crap. With a solid model, the database was basically a way of associating all those things to one particular entity, being the case. You'd call it a case. The database would see all these linked lists of objects that represent all these different little shapes and things that combined make up that half of the case. I don't know if it makes any sense. But some of the modelers, I mean, they gave you the ability of like grabbing onto this section right here, this piece, as a geometric entity and move it. And then as a result of moving that some distance, coming up with a new version of that model with that particular face change, which means all the connective surfaces and blends had to be updated to that new configuration. Not an easy task mathematically, but a big database exercise, and that's what happens with solid modeling. Well, these guys have got a system like that. I can tell just because of the shapes. Probably something like Dassault's CATIA, or one of the higher end CAD CAM packages, maybe what used to be called PTC. Well, what happens is now you have all these cool tools. The engineers are driven to get to market fast. And on a situation like this, not only are they being driven to get to the market fast, but they also have EPA and a bunch of regulations, which is really the genesis of a lot of these designs. Trying to make the combustion on a two-stroke efficient enough you don't make a lot of pollution based on government regulations. Net is you have these really complex shapes and designs, and they have to really play the edge with heat. So where I was heading with that is the CAD CAM systems. I mean, they help that, but they're a blessing and a curse, because not only do they allow you to design these very complex shapes and keep all the parts in very tight tolerances and be very compact and theoretically more weight and even energy efficient. They also provide tools for analysis, so before you actually make your first real saw, you can do things like finite element analysis for stress analysis or heat transfer, a whole bunch of other things that you have tools to do in the cyber world and software. And heat transfer being one of them. Imagine what you have to do to come up with a model of this particular saw, to come up with an accurate enough model to predict the heat and then the dissipation of heat through this whole thing. So these guys, they'll try to do things like that, and they'll make design decisions based on what they see, orders of magnitude. And then they come up with a saw as a collection of all that research and all that modeling and all that tweaks and changes and prototypes and stuff like that, but they are complex. And the one thing that I saw in the CAD CAM world, this is turning into a rant, I'm sorry, is back of, oh my God, 15, 20 years ago, machining was the big thing. Automation based on on certain parameters to automate certain machining operations. And there was this assumption that you could do that with a computer because, oh my God, it's a computer. And what people don't realize is the computer really is a summation of input of people. So in order to come up with good automated machining packages, just like you'd have to come up with the same kind of things for a heat transfer or a finite element analysis model to do heat transfer analysis, it's really the guys who are designing that model or designing that package who, based on their experience, come up with the parameters that decide how that package does its analysis, whether it's machining a pocket in a piece of aluminum to come up with a mold or a prototype, or a finite element analysis model to model heat transfer from, say, here to there. They've got to come up with these models and simulate their best that they can imagine how this is going to work, so they can come up with information that helps them come up with their final design. Well, I'm going to tell you that's tough, because it's limited on how much the man or people, the engineering group, can, in their mind, understand how these things operate in the real world. People are just so varied in how they operate. One guy might run a little more throttle, a little more RPMs, the chains are all different, the temperatures are different, the fuel's different, all these things. So of course they try to go to the lowest common denominator. But where this is going is this, what happens is, regardless of their best intentions and regardless of how good they are, they come up with their first best idea. It goes out, turns into a prototype. They get feedback based on their beta test or whatever they call themselves, and they throw it out into the field and see how it works in their customer base. But ultimately, when the more complex the design is, and the tighter the parameters, the performance parameters are, the more likely that the real research and development for the details is going to happen in the customer base. Now, the way the saw manufacturers deal with that is warranty and a series of upgrades. It's been this way forever. But with these new designs, I don't care whether it's Steel or Husqvarna, the first couple of generations of these things, there's going to be changes. Some will work fine. You know, it's a statistical game. It may be that 90% of them work and 10% have a problem, and that information goes back and they go back and update their design, and it's this evolution, this iterative evolution as these products work towards a more reliable form. Will they ever be 100% reliable? I don't think so. And that's why the warranty process is so important, but it's also why the dealers are so important. And I guess to try to wrap up my rant, this might end up being a video in of itself, is this whole series of saws, they are complex. You know, they tackled a very tough problem, even though it's one cylinder. The problem is not just the engineering requirement to come up with a saw with a certain power capability in a weight package. It's also price. I've said in my other videos it's kind of hard to out-engineer the engineers. That's what they do for a living. That's why these damn things are so cool. And you know, a lot of the people out there who take an existing design and modify it, yeah, they're smart, but I'll tell you what, none of those guys really have had the design from scratch, something that fits all those other requirements. The reliability in the dealer chain, the serviceability, the interchange of parts as they go through design revisions, etc. What a tough problem. And I'll tell you what, hats off to you guys over at Husqvarna. These guys, they're really cool saws, number one. But when I look at it from my old world's perspective, you guys have done a hell of a job, you know. And yeah, I could bitch about nylon versus steel bearings. I wasn't in your shoes when you made that choice. This is to you. But the net is these saws are fun. They are sophisticated. They have met a lot of those other challenges that got pushed on you guys. And they're cool. They're great running saws. They are not only, in my mind, a saw that matches what you'd expect out of a displacement of their, you know, of similar displacement saws from the past. They actually surpass the performance and meet the regulations all in one shot. So they actually are, in my mind, an improvement of the state of the art of the saws. So anyway, I think I'm going to turn this one off and get back to building this 550.